नमस्कार बच्चों, आप सभी स्वस्थ हैं? Let's go for this. Students, we are here with a lesson for class 9. This is atoms and molecules. What's the meaning of atoms? Here we'll study here, what is the meaning of atoms and how from the atoms molecules are formed. What are atoms? In your earlier classes, in 8th particularly, you studied about cells, which are the building blocks for the living world around us. Cells are the structural and functional units of life. In the same way, among the non-living world, whatever matter we study, in lesson 1, just recall, you studied that every matter constitute particles. There you gave the term particles, those small units of which the big matter are formed around us. You just named them as particles, but here you study the specific names of these particles. The specific name given to these particles is atoms. And in this lesson, we'll study about the how atoms constitutes to form molecules. Okay, moving ahead, there are your lesson begins with laws of chemical combination. Actually, these laws forms the basis which led the scientists conclude that the no living world around us is made up of matter. The first law which became responsible for this conclusion was it is law of conservation of mass. Conservation. Conservation means being safe, which remains safe. Okay. Conservation of mass means mass remains safe. Okay. In a chemical reaction, here a chemical reaction is carried out between the sodium sulfate and barium chloride. Na2SO4 is Na. In this lesson, you will study about the symbols of elements too. But here just remember that Na is the symbol of sodium and SO4 is the formula of polyatomic ion SO4, sulfate ion. So in total, this molecule is named as sodium sulfate. Okay, in a conical flask, we placed sodium sulfate solution and we put in a small test tube barium chloride. Okay, now the vessel is closed with a cork, showing that there is no interference of the outside environment. What we are going to do? We are going to measure reactants. We are going to measure the mass of the contents which are undergoing the reaction, and as you can see here, 300.23 grams is the mass of this conical flask with the cork, with the test tube, and the two kinds of solutions, sodium sulfate and barium chloride BaCl2, which are taking part in the reaction. Now, after we measure the mass of the reactants, we allow to mix them just in what the conical flask and allow the reactants to mix properly into each other. A reaction will take place. In class 10th in your next class, you'll study that such a reaction between barium sulfate and barium chloride and sodium sulfate is called double displacement reaction, in which these two reactants, sodium sulfate and barium chloride, these two reactants exchange their ions. Earlier it is sodium sulfate, means sulfate ions get attached with a sodium ion, and chloride ion is attached with barium ion. But after the reaction is over, sodium will become attached with chloride ion and sulfate ion will get attached with a barium ion. There will be mutual exchange of the two ions between these two reactants, and the new products get formed. Remember it, in your lower classes in 7th standard, you studied that those changes, those reactions in which new substances with totally different properties are formed, they are called chemical changes. So here a chemical change will take place, a chemical reaction will happen between sodium sulfate and barium chloride. But before carrying out this reaction, we have measured their mass as 300.23 grams, and then we carry out the reaction between these two reactants. Here the reaction is being carried out, and as a result of the reaction, new products Na. Na earlier was attached with the sulfate ions. Now it becomes attached with a chloride ion to make new product NaCl. And barium ion, earlier it was attached with a chloride ion, and after the reaction is over, it get attached with a sulfate ion, and the product so formed is barium sulfate. Okay, so and BaSO4, barium sulfate, and NaCl, sodium chloride, common salt that is used in your kitchen. Okay, so after the reaction is over, again we suppose measure the weight of mass of the two products. We find that if reaction is carried out in the closed atmosphere, we have placed the cork here. See, this is the cork. We have placed the cork here to protect the reactants from the surrounding effects, from the outside effects. So when such thing happen, the reactions are carried out in the closed atmosphere, the products will remain same, showing that whatever was the mass of the reactants before the reaction, same becomes the mass of the products even after the reaction, showing that there is no loss in the mass. There is no loss in the mass, which states the law of conservation of mass. What is the statement of law of conservation of mass? It states that mass can neither be created nor be any particles called atoms. Which two laws facilitates work between these two reactants? Two products were formed. By the bigger space with barium ion before the reaction, after reaction, they made bond with the sodium ion. So products are different. But one thing is surprising here, that whatever was the mass of the reactants before the reaction, same remained the mass of the products after the reaction, which states, which proves the law of conservation of mass. Moving ahead to the next law. This is law of constant proportions. What is this law? Before we state this law, let me let me think of water molecule. What is water? H2O, in which two hydrogen atoms, two hydrogen atoms are attached with one oxygen atom, leading to the formation of H2O. H2O. Okay, then this is H2O. This is oxygen atom, and with it there are connected two hydrogen atoms. Like you can see, this is the models of molecules will be available in the chemistry lab. This is a model of water molecule. Here is one more molecule. This is NH3, ammonia. Now suppose we collect water from the rain, or we get it from the pond, or we get it from the tap, or we get it from the sea. When chemical composition of water is studied, always we find that water is purely H2O. No sample of water will be NH3. No sample of water will be other than H2O. Always the chemical composition of water will be stated as H2O. And if we talk of ammonia, ammonia is a gas which is released in the marshy areas. Marshy areas means Daldali Ilake, where decomposition is taking place, resulting in formation of ammonia. Ammonia is a main constituent of human urine too. So, if we collect ammonia from these two samples, the gas which is released at the marshy areas and the compound which is present in human urine, and we carry out the chemical composition, we will find that each sample has ammonia as NS3, where one nitrogen atom is in bonding with three hydrogen atom. One hydrogen atom, second hydrogen atom, third hydrogen atom. So each nitrogen atom is in bonding with three hydrogen atoms. This is, this is the model stating ammonia molecule. NH3 is the molecular formula of ammonia, and this is the model of ammonia. And this is the model of water. Okay, so what is a constant proportion? Constant proportion is statement. What is that? In a chemical compound, the elements are always presenting definite proportion by mass. In a definite proportion by mass means in every sample. Whatever, whenever we study water molecule, we find that two kinds of constituent atoms, hydrogen atoms and the oxygen atoms, would be in fixed composition, would be in definite proportion by mass of 2 is to 16, where 2 means 2 units are the masses of two hydrogen atoms. Each atom of hydrogen has a mass of 1 U, and two hydrogen atoms makes one water molecule. So, by mass, if we say in each molecule of water there are 2 units of hydrogen atoms and 1 unit of oxygen atom, where the mass of one oxygen atom is always 16. So, whatever is the source of water, from all the sources, when water molecule is studied, the composition always is in the definite proportion by mass. That is, the definite proportion is 2 by 16, or in the simplified form, you can say it as 1 by 8 by mass. Okay, so 9 gram of water is decomposed if the 9 gram quantity of water is decomposed, we get 1 gram of hydrogen and 8 gram of oxygen. Because in water molecules, the hydrogen and oxygen atoms are in a fixed proportion of 2 is to 16 by mass. Ammonia, yet another molecule where each atom of nitrogen, that is just one in number, has the atomic mass of 14 U, and three hydrogen atoms. Each hydrogen atom has the mass 1 U, and because three hydrogen atoms are there, so by mass hydrogen is attached with 3. The simplified proportion in which the two constituent atoms makes this ammonia molecule is 14 ratio 3. So, two laws. Which two laws? Law of conservation of mass and law of constant proportion. When scientists lead to that during chemical reaction, when some chemical reaction is carried out, when some chemical reaction is might be consisting of the particles. Next, when constant proportion, law of constant proportion was formulated, then again scientists leads to the conclusion that the molecules are made up of still tiny particles which may or may not retain the properties of that particles. Atoms in fact retains the properties of the particles of molecules. Particles. These constituent particles are microscopic enough and they named them as atoms. In 1808, these two laws, law of conservation of mass and law of constant proportion, these laws came by the end of the 18th century. Around 1793, Lavoisier carried out his several experiments and formulated these laws. Now, on the basis of the laws formulated by the end of 18th century, in the beginning of 19th century, the year 1808, it was the John Dalton, an English person from England. He stated some informations about these tiny particles of matter on the basis of the laws formulated by Lavoisier. Uh, Dalton some informations in the form of atomic theory, which is very, very you to understand particular matter may it be solid matter like chart piece, like a pen, the notebook over which you write. These solid matter contains atoms. If we talk of liquid matters, they are made up of molecules. The water we drink, that is made up of molecules with formula H2O. But still, these molecules are further made up of two hydrogen atoms and one oxygen atoms. What he said in his first information is that matter is made up of tiny particles called atoms. What next is that atoms are indivisible, means they cannot be divided and cannot be created or destroyed in a chemical reaction. He said that atom is indivisible. They here at this point of time, at a later stage, you will study that John Dalton gave absolutely many correct informations about atom in his theory. But here he committed the mistake. Here he was wrong when he said that atom is indivisible. Anyhow, we'll discuss it later. Okay, atoms are indivisible and cannot be created or destroyed. This is, he was right. We really cannot create atoms or destroy atoms in a chemical reaction, and this was proven by law of conservation of momentum. So, second postulate of the Dalton's atomic theory was on the basis of law of conservation of mass. Here you can be asked in the exam that which postulate of the Dalton's atomic theory supports law of conservation of mass. So you can say this is the second law in which Dalton stated that atoms cannot be created or destroyed in a chemical reaction. Atoms cannot be created. You just can't create any atom artificially, or you cannot destroy any atom artificially. In the chemical reaction, before the reaction and after the reaction, the masses of the reactants and the products are always remain same, which is stated in the law of conservation of mass. Then atoms of the given element are similar in mass and properties. Suppose you collect some sample of iron in the form of iron bar, you understand, saria. And some you have the rectangular piece of iron. Okay, anyhow, you study the atoms of iron in this iron bar as well as in this piece of iron. You will find that the atoms of both the samples of the given element will be similar in mass and properties. Mass and properties of the atoms of both these samples will be same. Opposite to this, atoms of different elements have different masses and properties, which means that suppose you have a piece of iron and you have another piece of aluminium foil in which your mother wrap your chapati. Okay, so aluminium foil and the iron. When you study the two atoms of these two elements, you will find them absolutely different in masses and properties. Here also, now the exceptions are available against these two postulates. At a later stage of this lesson, we'll study about what are the exceptions of these two postulates. But till then, you can consider to be a Dalton atomic clock. It went very long. For many years, scientists believed that the information provided by the Dalton was absolutely right. Then, atoms combine in small whole number ratios to form compound. Okay, means when molecule water is formed, then, to make this molecule, two hydrogen atoms and one oxygen atoms, these two atoms remain in the small whole number ratios of 2:1. Two hydrogen atoms always combine with one atom of oxygen to make one H2O molecule, to make one ammonia molecule. One atom of hydrogen combines with three hydrogen atoms